Hello everyone, welcome back to JavaMentor.net. Let's learn the difference between list and array. Okay, this is a very common interview question, and let's first try to create one array. Take a note that I am creating a list of big integer wrapper class, and I created one array. Let's remind ourselves from the previous video. When we create an array of 10 elements, fixed size, Java will already allocate the space in the memory for all of the elements. So if one integer is 16 bytes in memory, which is true, then for 10 elements, Java will allocate 160 bytes for an empty array. And you remember that when you create an array in this fashion, Java will add 10 default elements inside. And I just run a debug mode, and as you can see, if I try to print sixth element, it will print null. So all elements inside this array are null, and there are already 10 elements, 160 bytes of memory. The next thing which is important is that those elements, let's say that this is our memory, those elements are one next to each other. Something like this, and all of them are null, and you may argue, well, it's stupid to reserve memory when they are not holding any information, but we will see until the end of the video why is Java doing this. Okay, let's add some elements to this array. Okay, I added some elements, populated the array, and that reflected the memory, right? So now in our memory we are holding the real information. Now, let's say that we want to get this element. So this element is 7th element, right? We can say something like this. Let's say to print that element. Spendings of 6, right? And what's the whole point? How will Java fetch that 7th element from an array? So let's say that the address of the first element is 100. Something I will write here. So address of the first element is 100. Then what's the address of this element? Well, Java can calculate that. So we know that the size of one element is 16 bytes. So if this is the first element, then 7th element in an array would be address of first element plus 7 multiplied by the size of the element, which should be 212, right? So if you access the memory 212, you will get the 7th element. The point is, Java can instantly jump to some position in the array. Let's say that we have a million of elements, and we have to access the element on the position, let's say this one. Okay, the same logic applies. Address of the first element plus how many elements we want, what is the index of that element that we want to access, multiplied by the size of one element, and that is some number, right? Go to that address and you will find that element that is standing on that position. You can do that instantly. You don't need to go element by element. And this is how array is functioning. Okay, now the question is, you remember that we cannot add or remove elements from the array. That's because if you pick one element and move it out, then elements are not one next to each other anymore. So this is the exact reason why you cannot remove elements. Now you're losing the feature that you had previously, that elements are one next to each other. And the same point is for adding elements. If elements in the array are one next to each other, You cannot put another element between those two because that will require to move all of those elements, to the right, which is a very costly operation. So let's summarize pros and cons for the array. The biggest problems with the array is that you cannot add elements and you cannot remove elements because you don't want to screw up the ability of the array that one element is next to each other. So no adding, no removing. The biggest advantage of array is that you can access element on certain positions very fast. You don't need to go through every element. You can just calculate the address of element that is on position 1 million, let's say. Also, the problem with array is that initially when you create an array, empty array like this, so even if you don't add any element, you will allocate a memory. So you remember we allocated memory when we created array. And that's, a slight problem with array that we can live with. Now let's move on to the list. If we try to create a new list, let's say list of integers, list of numbers equal new array list. Well, this array list is basically working the same as array. It's just an object and you get a plenty of useful methods. For example, contains all, add last, add first, so you don't need to bother yourself too much with implementing those features. But it's basically working, array list is basically working the same as array. And the real representative of the list is actually a linked list. Okay, how this linked list look like in memory? Well, when you create linked list like this, Java will allocate one very small chunk of memory for that list. So this is the whole list. Let's say this is 10 bytes, for example. So list initially 10 bytes. So when you want to add a new element, let's say you say add 25, so you added one number. What will happen? Well, new element will be created on our memory, somewhere in the memory. It doesn't need to be next to the list, so it can be here. Here is our number 25, and you'll have a pointer. So, something like this. So, if you want to add another number, let's say 125, you'll have new element in the memory. Let's say that element is here. You'll have a pointer to the new element, and that will be 125. And now, if you can see, we said this is 10 bytes, and we know that each element is 16 bytes. So in total, we are acquiring 42 bytes for those two elements. If we add new element, let's say the new one is somewhere here. So it's very important to notice that those things are randomly inside the memory. Let's say the new element is 56. And now you have 3 times 16 bytes plus 10 bytes initially. That's the consumption of the memory that we are using. And what's the thing here? How can we add a number between those two numbers? Because we say that we can add new numbers, we can remove numbers from the list. Let's say that we want to add one new number between those two. Well, it's very easy. Just delete this line. How Java is doing that? Delete that line, create new element, and now this pointer is pointing to that element, and that element is pointing to the next. If we want to, let's say, whatever, that element is 34. If we want to remove that element, Java will remove that element, and it will connect those two with the pointer. So the biggest good thing about list is that you can manipulate that list by adding or removing elements on the fly. And you don't need initial memory like we needed in the array. So much less memory initially, and you can manipulate elements. However, the biggest problem with the list is that if you have a million elements connected in this fashion, in order to find the element on this place, let's say, you cannot calculate the address of that element because they are not next to each other, they are randomly assigned in the memory. You need to go through every element and through every line. So if you need element on the position 1 million, you will need to go through million elements to find that element which is standing on a position million, which is very slow. So basically, if you want how to choose between array or list, between those two structures. If you want some structure where you will many times add or remove elements, but you will not search by position, then you need this structure, list structure. On the other hand, if you want, if you have a use case that will initially add some elements to that structure, and then in the future it won't change so much, but you will search many times based on the position, then you need array. And the last small thing to say, this list only has a pointers forward. You cannot go from this number backward, something like this. So you can imagine that, I'll just delete this line so you can see. So you need to have two pointers, one from this number from 25 to 125, and sometimes you want to go backwards, so you need a pointer to the previous element. And basically this linked list is double linked list, so it has those pointers backward. I mean, it's totally possible to create a list which is only pointing forwards. Some use cases are in some use cases that is what we want, but sometimes we want to have pointers backwards as well. And it's important to say that this linked list is actually double linked list. It has backward pointers as well. In the next two tutorials, we will learn about hashing, we will learn about hash sets, we will learn about binary search, and all of those things are using actually arrays. So they are using a data structure where elements are one next to each other, and you will realize in the following tutorials why is that. See you in the next tutorial.